It is a right angle triangle.
Pythagorean identity.
Pythagorean identities. We'll start with everything. Let's say this is A, B, and C.
C.
Or H. H for hypotenuse. So for theta, opposite is A, adjacent is B, and the hypotenuse is always opposite 90 degree, which is H. So here we see that sine theta will be equal to A upon H. Cos theta is B over H. And tan theta
is A upon B.
Right. Then cosec theta, which is a reciprocal of sine
H
theta,
over A.
H over A. Then sec theta is
will
H over B.
H over B.
And cot theta is B over A. Also, using the same right angle triangle, we can see that tan theta will be equal to sine theta divided by cos theta. Because even though if you see sine theta, it is A upon H divided by B upon H, H gets cancelled, you get A upon B, which is supposed to be tan theta.
Yeah.
Therefore, we can also say that cot theta, which is the reciprocal of tan theta,
will be cosine over sine.
Yeah, cos theta over sine theta. Then, since we know that A square plus B square is equal to what? H square. Therefore, using this Pythagorean identity, A square plus B square is equal to H square. If we divide every side by H square, we will end up getting A square over H square plus B square over H square is equal to 1. Right?
And that is just sine squared over,
Yes, that is sine theta squared plus cos theta squared is equal to 1. So we can also write them as sine squared theta plus cos squared theta is equal to 1. This is one identity. And from here, we can also understand that sine squared theta is equal to 1 minus cos squared theta. Right?
Yeah.
Where we can also say that it is equal to 1 squared minus cos squared theta, and hence I can also write them as 1 plus cos theta into 1 minus cos theta. This is the factorization of sine squared theta.
Difference of squares.
Difference of the squares. Similarly, we can say that cos squared theta, which is equal to 1 minus sine squared theta, can be also written down to be 1 plus cos theta into 1 minus
sine.
My bad. 1 plus sine theta into 1 minus cos theta. Right. 1 minus sine theta. What I'm doing. Okay, that is about cos square theta. Now, since sine squared theta plus cos squared theta is equal to 1, cos squared theta is equal to 1. If we divide each and every side, let me say that by cos squared theta, then sine squared theta divided by cos squared theta will become tan squared theta. And then we get plus 1, which will be equal to 1 upon cos squared theta.
So 1 upon sec. Sec squared.
1 upon cos is sec. So sec squared theta. This is another Pythagorean identity. Fine. From here also.
Do the opposite. Okay, yeah. It will be 1 plus cot. Yeah.
From here we can also say that sec squared theta minus 1 is tan squared theta. And sec squared theta minus tan squared theta is equal to 1. And you can also get a difference of the squares out here. That sec theta plus tan theta into sec theta minus tan theta, that will also remain 1.
And then I guess similarly 1 plus cosine over sine, so 1 plus cot squared will get sec. We'll get cosec. Yeah.
Correct. That is also right. So I will just finish it writing here once. So we can get, if we divide everything by sine squared theta, then you should get 1 plus cot squared theta, which will be equal to cosec squared theta.
Yeah.
So 1 plus cot squared theta will be equal to cosec squared theta.
Yeah.
Cosec squared theta. Therefore, again, you can say that cot squared theta is equal to what? Cosec squared theta minus 1. You can even factorize this. Okay, you'll have to, but if you remember original formula, then you will understand all the forms of it. And again, I can say that cosec squared theta minus cot squared theta will be equal to 1, which leaves us cosec theta plus cot theta. Cosec theta minus cot theta is equal to 1.
Yeah.
Fine. So these are some identities. Based upon that, we have one whole exercise which we can practice. Fabio book. I will just share it with you. What exercise I'm talking. So I'm talking about this entire exercise. 10.2.1.
Yeah.
If you want, we can.
I don't have the book with me now, but yeah.
No problem. I will send it to you. So I'll put it in this thing only, the file which I'm creating for you, so that you can have a look.
No, I have the PDF. Wait, 10.2.1. Wait, I'll just open it myself. Yeah. Yeah, but if you just zoom in, it's fine. Yeah.
10.2.1.
Yeah.
All the questions, in fact.
Which exercise would you like me to do from that?
As of now, if I want you to solve these questions for sure now, but then we can just go for alternate questions. Let's start with C and then H.
Oh, one thing I forgot to tell you. Can you review one question we did in class? I'm still quite a bit confused.
Tell me.
Wait, I'm just gonna find it and send it to you.
Okay.
It was a pulley one.
It was a pulley one. Okay. Fine. From this book only?
No, from past paper.
From the past paper. All right. You remember that I made a general formula for it?
Yeah.
With you only I had made a general formula. It is the same logic to be applied, but I'm happy to review for it. Okay.
I sent it.
You sent it?
Yeah. WhatsApp.
WhatsApp, I see it. Yeah. Here is the question. The two discs, one of the radius is 8 centimeter and one of the radius is 5 centimeter, are placed in such a way that they touch each other. A piece of string is